Means if we consider triad, means two elements and one in between. So with the knowledge of the two elements like lithium, sodium, potassium, if we can consider lithium, sodium, potassium, so if we know the property of lithium and potassium, we can identify and find out the properties of sodium. So that was the concept of Daubigny. But his concept was failed when he has proceeded more into depth of heavy elements. So that was not worked into. Next, Newlands in 1864, he gave another a beautiful law, that is the law of octaves. So what he said is that if we go according to the atomic weight, previously the scientists who were there in 18th century, they considered that according to the increasing atomic weight only we are going to arrange the elements. So that will be, discrepancy will be found out later and that will be solved out. Now, octaves means if every 8 elements, means 1, 2, 3, 4, 5, 6, 7, 8. Every 8 element will have the repeated properties. So that was being told, and later on after he has discovered, there was a huge shout out that some discoveries were being made. But at last it was seen that when the calcium has come out, so he could not got the answer for it, and that was also cancelled out. Now comes a Mendeleev's breakthrough. This was a major breakthrough whenever the Mendeleev got into it. But the thing is that he has arranged the elements according to the increasing atomic weight. According to the increasing atomic weight, he tried to arrange the element, and he said that in a particular row, if there be atoms with the increasing atomic weight, if they can arrange it in a table, the similar element will having the similar properties. But later on that was also having some discrepancies, and that was being discarded or sorted out, not sorted in. So that was not considered. Next, incorporation of atomic structure by Henry Moseley in 1930. He has found out the periodic law. So periodic law on the basis of the atomic number. So here comes the importance now, from where he started. So from Moseley, 19th century, that is 1913, the periodic table has got some inspiration and some breathing. So for what they have arranged, he has arranged according to the increasing atomic number. But in some discrepancies were still there. So as the atomic number got into it, that means there was a discovery of electrons, there was discovery of protons. Because atomic number is the number of electrons, as well as we can consider atomic number as the number of protons present in the nucleus. So this is also atomic number. So atomic number will indicate both the number of protons and the number of electrons. So the particles were sorted out here from his discoveries. Now comes Chadwick. In 1932, he has discovered neutron. So discovery of the particles were given, and after that comes the completion. So comes the completion means whenever there was the study of higher elements like atomic number more than 92, they could not place this in that periodic table. Whatever table is being given by Mendeleev, Moseley, Daubigny, whatever they have said, but when the heavier, super heavy elements have come into, they could not place the element that in that particular box in groups 1A, 2A, 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 2B, 3B, 4B, 5B. They could not arrange it in this way. So they have got certain separate rows for the super heavy elements like lanthanides and actinides, and this particular, and left some gaps for total. We are having 118 elements till now, it's known to us, and that was being sorted out, and giving a separate row and place for lanthanides and actinides. The modern periodic table was being settled down, and it was handed over to everybody study and see the properties according to the sorting of properties according to the groups and patterns. So that's all for the periodic table evaluation, and thank you so much.